Hi, today we are going to discuss about our project investigating the environmental and economic indicators of agriculture in Canada. The main purpose of our project is to understand the various factors involved in agriculture, such as environmental and economical impacts. We aim to understand this through the use of various visual elements on indicators, such as residual soil nitrogen content, pesticide or fertilizer usage, land usage, and the production yields, etc. We also compare them across different provinces. We aim that these dashboards will be helpful for the provincial and the federal governments to create sustainable path towards agriculture as well as for farmers to be able to practice better farming methods. In the first dashboard, we can see the residual soil nitrogen content and its risk on water contamination. Residual soil nitrogen is the excess nitrogen left in the soil after each cultivation season. In the left pane, we can see a heat map of various farming lands across Canada and their aggregated residual soil nitrogen content over the years. The line graph on the right gives the comparison between the residual soil nitrogen content and the water contamination levels by nitrogen over the years in Canada. The stacked bar chart provides us with the contribution of each of the provinces towards the overall factor over the years. We can also use the filters to visualize the residual soil nitrogen levels or the water contamination by nitrogen levels across the provinces. Similarly, we can also brush over the line graph to see the corresponding values change in the map and the bar charts. We can also select between multiple provinces to compare and contrast them for specific years. In this dashboard, we can see the usage of fertilizers and various pesticides. In the first graph, we can see a heat map of the usage of various fertilizers and pesticides across the provinces in Canada. Using a line graph, we can see the trends of pesticide concentration in water. To compare the use of fertilizers and pesticides across provinces, we can use the side-by-side bar graph. We can now use the brushing and the linking techniques to select specific provinces and compare across their values. Brush and select specific years from the line graph. Moving on, this dashboard provides a comprehensive overview of the agricultural revenue trends in various Canadian provinces. This dynamic dashboard delves into the key aspects of agriculture, including crop production trends over time using a stacked area chart that helps us to understand the contribution by each province to the overall production levels. The relationship between land area and production using a scatter plot, the area of land dedicated to crops across the provinces over the years, and the farm income fluctuation over the years. We can filter based on the various income components. We can use brushing and linking techniques to select a particular area in one of the graphs to see the values change in other graphs correspondingly. The use of scatter plot here helps us to understand the relationship between the area of farming land and crops in acres and the production output. Similarly, the use of line graphs helps us to see the trend of farm income over the years. The final dashboard showcases a comparative visual analysis of other critical agricultural environmental indicators among different provinces. The spatial heat map on the left shows the greenhouse gas emission across different provinces. The bar graph on the right shows the soil organic matter across the provinces. The side-by-side bar graph on the bottom helps us to visualize the average soil erosion. We can also brush and select certain provinces to compare the values.